Introduce gravity the way the world understands it. For over 300 years, humanity believed gravity was a force, a pulling interaction between masses. This view was formalized by Isaac Newton in 1687. Explain. Falling apples. Planetary motion. The inverse square law. Predictive power of Newtonian mechanics. Clarify something important. Newton's model works extremely well for engineering, space missions, bridges and buildings, satellite trajectories. This is not about Newton being wrong. It's about Newton being incomplete. Create tension. If gravity is a force, why does it act instantly across space in Newton's equations? That question bothered physicists for centuries. Shift the tone. Ask the viewer. If gravity is a force, what is doing the pulling? How does Earth reach out to grab the moon? What carries this force? Introduce the conceptual issue of action at a distance. In physics, forces are usually transmitted by something. Electromagnetism, photons. Strong force, gluons. But Newton's gravity had no mechanism. It simply worked. And that made it mysterious. This unresolved tension sets the stage for revolution. Now introduce the turning point. In 1915, Albert Einstein did not try to fix Newton's force. He removed it. Einstein proposed something radical. Gravity is not a force. It is the curvature of spacetime. Explain the core shift. Mass does not pull. Mass bends spacetime. Objects follow the straightest possible path in curved geometry. Introduce the term General Relativity. To understand gravity without force, we must redefine reality itself. Before the 20th century, space and time were considered separate. Space was a stage. Time was a ticking clock. Then Albert Einstein unified them into a single structure. Spacetime, a four-dimensional fabric combining three dimensions of space and one of time. This was not philosophical. It was mathematical. Events are not in space and in time. They occur in spacetime. And this structure can bend. Here is the central idea. Mass and energy tell spacetime how to curve. Curved spacetime tells objects how to move. The rubber sheet analogy is simplified. Real curvature happens in 4 dimensions, not 2. Earth does not pull the moon. Instead, Earth warps spacetime. The moon moves along the curved geometry. Its orbit is simply the straightest possible path in curved spacetime. In physics, that path is called a geodesic. No force required. If gravity is geometry, why do we feel weight? The answer is counterintuitive. You are not being pulled downward. You are being prevented from falling freely through curved spacetime. When you stand on Earth, spacetime is curved toward Earth's center. Your natural motion is to move along that curve. The ground stops you. That resistance is what you feel as weight. Astronauts in orbit feel weightless not because gravity disappears, but because they are freely following spacetime's curvature. They are in continuous free fall. Gravity is not pushing them down. They are moving naturally through curved geometry. A scientific theory becomes powerful only when it makes predictions. In 1915, Albert Einstein predicted something extraordinary. Light should bend when passing near a massive object. According to Newton, gravity affects mass. But light has no rest mass. So why would it bend? Because in general relativity, gravity is not a force acting on mass. It is curvature acting on spacetime itself. Light always follows the straightest path in spacetime. If spacetime is curved, that path appears bent. In 1919, during a solar eclipse expedition led by Arthur Eddington, scientists observed starlight bending around the sun exactly as predicted. Newton's force model could not fully explain it. Einstein's geometry could. Gravity was no longer just theory. It reshaped astronomy overnight. If gravity is spacetime curvature, then not only space bends. Time bends too. clocks run slower in stronger gravitational fields. This is called gravitational time dilation. The effect is small near Earth, but measurable. Modern GPS satellites must correct for it constantly. Without Einstein's equations, GPS would drift by kilometers per day. This is not philosophical physics. Your smartphone works because gravity is geometry. Time itself is warped by mass. The most dramatic confirmation came in 2015. The observatory known as LIGO detected gravitational waves. These were ripples in spacetime caused by two merging black holes over 1 billion light-years away. Think carefully. Not waves in space. Waves of space. If gravity were just a force, this detection would not look like spacetime stretching and compressing. But LIGO measured spacetime itself changing length smaller than a proton's diameter. That was direct evidence that gravity is dynamic geometry. If gravity is the curvature of spacetime, then a black hole is not a vacuum cleaner pulling everything inward. It is a region where spacetime curvature becomes so extreme that all possible paths lead inward. According to general relativity, when enough mass collapses into a small enough region, spacetime folds into itself. At the boundary of a black hole lies the event horizon, the point of no return. Once crossed, every possible future path in spacetime points toward the center. No pulling. No invisible force grabbing you. Just geometry so steep that escape paths no longer exist. For decades, black holes were mathematical predictions. Then in 2019, the Event Horizon Telescope released the first direct image of a black hole. The target, the supermassive black hole in galaxy M87. What we saw was not the black hole itself. We saw the shadow, light being bent and trapped by extreme spacetime curvature. The glowing ring exists because photons orbit in curved spacetime before escaping. This image was not a photograph of a force. It was a photograph of warped geometry. At the center of a black hole, Einstein's equations predict a singularity, a point where curvature becomes infinite. And this is where physics breaks down. General relativity describes gravity perfectly on large scales. But at singularities, it conflicts with quantum mechanics. This tells us something profound. Gravity is not just geometry. It is geometry that we do not yet fully understand. There is no confirmed theory of quantum gravity. Leading candidates include string theory, loop quantum gravity. But no experimental verification exists. At the edge of black holes, reality itself becomes uncertain. After everything we've explored, the natural question emerges. Was Isaac Newton wrong? No. Newton described gravity as a force because, at everyday scales, that model works perfectly. Bridges stand. Planets orbit. Rockets launch. Newton's equations remain operationally valid in weak gravitational fields and low velocities. But they are an approximation. When gravity becomes strong near massive stars, black holes, or at relativistic speeds, Newton's force picture fails. That is where Albert Einstein takes over. Science did not discard Newton. It refined him. Yet Einstein's theory is not the final word. General relativity describes gravity as smooth curvature of spacetime. Quantum mechanics describes reality as discrete and probabilistic. The two frameworks are mathematically incompatible at extreme scales such as inside black holes or at the Big Bang. Physicists suspect that gravity may have a quantum carrier particle, often called the graviton. But no graviton has ever been detected. This leaves us with a paradox. On cosmic scales, gravity is geometry. On quantum scales, the true nature of gravity remains unknown. The force may reappear in a quantum description, but not in the Newtonian sense. The search for quantum gravity remains one of the greatest open problems in physics. So what is gravity? It depends on the scale at which you ask the question. At human scale, gravity behaves like a force. At cosmic scale, gravity is curved spacetime. At quantum scale, we do not yet know. The deeper truth is this. Gravity is not something pulling you down. You are moving naturally through curved spacetime. The ground pushes you upward. Weight is resistance to motion through geometry. And the universe itself is not held together by invisible strings of force. It is structured by the shape of reality. Close the documentary with a final, authoritative statement. Gravity is not a force. It is the architecture of spacetime. And we are still learning how that architecture truly works.
Subscribe Info Beyond Borders now for more mind-blowing knowledge.